Hi, you guys. So I am gonna make a quick video on the universal law of gravitation to help you guys out with that DO4 module and check for understanding. So I'm just gonna go over the formula, how to use it, and kind of go through two example problems to help you guys out. All right. So for the equation that you guys are gonna use for this problem, the first thing you guys want to write down is the force of gravity is going to be your gravitational constant times one mass times another mass all over the r squared. What that's basically saying is that if you had an object here and an object here, there's some sort of space between them. That space is called r. This is object 1, this is object 2. And then what's going to happen is with two objects, they're actually going to be pulled together, right? So like think about it like two planets. There's gravitational force between the two planets, but there's also gravitational force between two people sitting down, or two pencils sitting next to each other. So there's always some sort of force pulling on these two objects. That force is called the force of gravity. So I'm going to walk you guys through how to complete this. So the first one is there's two students sitting on a bench, or sitting. It doesn't say bench, but they're sitting. They're 1.5 meters apart. One student has a mass of 70 kilograms, the other has a mass of 52. We're looking for our gravitational force. That's what we're trying to look up. So our force of gravity is right here. Our gravitational force, or our gravitational constant is G. The gravitational constant is basically a number that's given to you, and it's always used in this problem no matter what. It's just a constant. It's going to be plugged in. It's not going to be written in your equation, but you guys should know this constant. So I'm going to start plugging in my values. So I know G. I know that G is going to be 6.673, and it's always that, no matter what. That's your gravitational constant. So that's always G. My M is given to me. My first mass is my first student is 70 kilograms. My second student is 52. And then the distance between the two is going to be 1.5. Values and I'm looking for G. The first thing I'm going to do is I'm going to start simplifying. So I know if I start simplifying 1.5 squared, calculate 1.5 squared should be 2.25. Multiply all these together. So I'm going to take 6.673 times 10 to the negative 11. So you should get a really, really small number. All right? I'm going to times that by 70. And then I'm going to take that number and I'm going to times that by 52. So now if I look at this, my decimal place is actually going to be 1, 2, 3, 4, 5, 6, 7. So it should be 2.42 times 2.42 times 10 to the negative 7. And all I have to do is basically take that number, which is the same thing, and I have to divide it by 2.25. So my final answer should be 1.079, or actually 1.08 times 10 to the negative 7. So my final answer is going to be 1.08 times 10 to the negative 7, and that will be in newtons. So my final answer, my force, is going to be 1.08 times 10 to the negative 7 newtons. That's all you really have to do is take these values and plug them back into your equation. So hopefully that helps you with just the standard universal law of gravitation problem. There's a couple different ones. I'm going to take you to number 5. Number 5 is a good example of one where you have to find the mass of the object. So if we look again, the gravitational force between two objects that are 2.1 times 10 to the negative 1 meters apart. This is the total of the force. The mass of one object is 55. What is the mass of the other object? So I'm just gonna write my formula out. Oh, let me erase that. My gravitational constant. All right. So now I'm gonna start plugging in what I know for sure is I do have a force. So I have my force right here. So I'm gonna write down that I have 3.2 times 10 to the negative 6 newtons. I do have my g, which is going to be 6.673 times 10 to the negative 11. I do have my first mass, which is 55. I'm looking, if you guys can see, for my M2. It wants to know what the second mass is. So if I'm looking for my M2, I'm going to basically try to solve for it. So my distance is going to be 2.2 times 10 to the negative 1 meters, and then I need to square that. All right. So my first thing is I'm going to get rid of this square, right? I want to get rid of it so that way I can move this whole thing to that side. Okay. So I'm going to clear my calculator. It should be 2.2 times 10 to the negative 1. So it should be 0.22, and then I'm going to square that. So this whole part at the bottom is going to be 0.08 or 0.0484. So let me erase this down here. I'm going to rewrite this since we got rid of it. And it's going to be 0.0484. All right, that's my new value since I got rid of the square. So now what I want to do is I actually want to get it away from the bottom, and I want to times this whole side of the problem by that number so I can cross it out. And so what I have to do is I have to times it to this side, which is going to be 0.0484. So now let's plug those numbers in. So I have this one. I'm going to times it. I'm going to use a bracket to make sure everything is good to go. So it should be 2 times 10. Oop. So it's 0.0484 times 3.2 times 10. Okay, so those together, once I times this one and this one, my number would be, let's move this decimal place over, 1, 2, 3, 4, 5, 6, 7. It's going to be 1.55 10 to the negative 7. So I'm going to go erase this value, so I can save some room. And come up here, and it was 1.55 times 10 to the negative 7. All right, and let me erase this because now I got rid of it. So now we're slowly breaking down our equation. Now what I want to do is I want to combine this term and this term. So the next thing I want to do is basically take these two and combine them together.